Got it.
And we can start. It's okay. Or...
Yeah,
okay.
That's fine with me. Yeah, now that you're recording, and
okay.
people can watch it later if they come along.
Yeah, obviously, since it's still late class time, it might be around. I'm sure people will join soon. But first of all, thank you for honoring us today. It's my honor and pleasure to introduce our keynote speaker, Dr. Michael Gould, who is going to talk about the state of the art of GIS today, as you can see from the slide. He is the guru and glue, I would say, of the Esri educational team, working over 85 offices to see the special thinking into our GIS curriculum. And plus, he's working as an educator at Universidad Juli to continue this mission at the academic level. But today I would like to share something probably he might even not remember. I met in person with Mike while I was in Agile. It's the Association of Geographic Information Laboratories in Europe in year 2011. My trip to the conference was possible thanks to the Esri's student travel grant. And Mike just sent an email that he wanted to meet us, all the students who were awarded. And I was trying to recognize what it looks like in the conference. And he seemed like a very busy guy, like talking to everybody that day. And I thought, oh, he'll just say hi and then maybe leave because he's obviously has full. But once he was with us, it felt like he just paused the time, just focusing only on us. And he wanted to know us, why we are enthusiastic about GIS, why we are there, what our research is. And it was a real enthusiasm that he showed. And that really sparked a sign on me that he's a great mentor too, that we can learn from. And today, hopefully we'll learn a lot from his talk. And please join me welcoming Dr. Michael Gould today.
Thank you very much. And thank you for the kind introduction. Yeah, we always like to meet students and know what they're studying and what their plans are. Of course, we'd like to hire a lot of them. So it was great that we met back then. And one of the topics I'll touch upon is that the GIS world is such a small world. We're all so intimately connected by just a few links. Let me kick off here. And I deliberately said a state of the art. This is not the state of the art. This is these are my opinions, and it's basically a sort of a quick tour of some observations that I make about our industry, our sector, based upon my experience and based upon both wearing my academic hat. By the way, I have my UMass alumni hat that I'm not going to wear, but I have it here. And I'm actually kind of disappointed. I think it should say alumnus, because I don't know why it says alumni. I would feel kind of uncomfortable wearing it, but anyway. So when I'm wearing my academic hat, I have certain experiences. And when I'm wearing my Esri hat, I have other experiences. So I'll talk just a little bit about that in these next few minutes. So, of course, happy GIS Day. It's been around since 1999 when it was created by Jack Dangerman, interestingly, at the urging of Ralph Nader, with a conversation that he had with Ralph Nader talking about how there should be some sort of an annual celebration. And so Ralph Nader encouraged him to create such an event. And so it's been going strong ever since. And let me just fire up a little video here, which I think is a nice kind of collection of things that are going on in our world. I think it's good to set the stage here.
Our world gets smaller. What happens somewhere else? Closer and closer to home. Much the world wants to know.
We don't know a lot of things.
I think there's a
We
lot of
don't know.
questions out there.
People very insecure.
It's not enough to know we're interconnected. We have to understand how and collaborate to build a better future. Your answers matter more than ever. Thank you for your vital work.
So it's just kind of to kick things off. We're really impressed by all the things that our users are doing around the world. And we really believe that GIS is, in a sense, behind the scenes powering the world. It's powering a lot of the decision making around the world. And so just as a quick refresher of GIS history, sort of how did we get to where we are now? There was a lot of background work that happened in many countries around the world, but essentially GIS began in Canada with the Canada GIS in the 60s, created between Dr. Roger Tomlinson, a geographer, and a bunch of people at IBM who were selling a big computer. So it was a sort of interesting match between sort of the geographer who wanted to help the Canadian Natural Resources Ministry, essentially, take better stock of their forest resources and to make decisions about their forest resources based on digital data, not just paper maps. And so this is an interesting sort of example, first example, where GIS was created to make decisions, not just to make maps. Back then, GIS was a bespoke, customized system, each one made specially for each customer. And that, of course, wasn't scalable. So eventually, companies like Esri and Intergraph were created and essentially built general purpose GISs. And so the first of which was called ArcInfo. That was Esri's product. It was the first sort of toolbox that users could utilize to create their own GIS without having to contract programmers to build something specifically for their needs. And the ArcInfo name comes from two sort of subsystems. The Arc system was dealing with the geometry, the points, the lines, and the polygons, let's say. And then the Info system was a relational database product from a company in Waltham, Massachusetts, actually. It was called Info. So they matched the info with their own geometrical engine, let's call it, and it became ArcInfo. Around the same time, GRASS, a very well-known open source product, so the Geographic Resource Analysis Support System. I have a little reminder over here on the right side. If you Google, if you do a search for GRASS video 1987, you'll find a hilarious video by the creators, who are the Army Corps of Engineers, talking about, in sort of typical 1980s style, you know, how wonderful the technology is. The funny thing is, it's narrated by William Shatner, of all people. So have a look for the GRASS video and you'll have a good laugh. Interestingly about GRASS is that it's still around and it's a bunch of open source code that people are playing with, and it's mostly a raster or an imagery based system. In the 1990s, it was running on Unix workstations. And one of the people in Boston who was selling these Unix workstations, he was working for a company called MassComp, the Massachusetts Computer Corporation, which no longer exists. And these MassComp Unix workstations were, big expensive boxes. And David Schell decided he was going to utilize GRASS and some other sort of GIS type of software as a way to illustrate the power and the usefulness of this big, expensive workstation. So he became a GRASS user and started finding that he was finding interoperability problems between GRASS and other software and other data types. So he went on to create the OGC, the Open Geospatial Consortium, based upon his own interoperability problems as a salesman of MassComp workstations to run GRASS. So it's sort of a theme of this talk that everything's very, very tightly connected in our GIS world. So around the same time, he created OGC in '94. And then turn of the century, this century, GIS became more distributed and more interoperable. We started connecting more pieces and it became a little bit more flexible. And around those same years, several notable open source products and projects, such as PostGIS and the OSGeo community was formed and the Quantum GIS was created. So this was a time of a lot of sort of, well, you might call it innovation, you might call it copying, but in any case, lots of alternatives for people in the software world. And of course, the commercial vendors were moving forward and continue to move forward. The Oracles and the Googles, et cetera, are still innovating. And here's Jack and Laura Dangermond, our founders, the founders of Esri. Started the company in 1969 with $1,100 from their own family. And since then have never had any loans, never had any investors, never had any shareholders. It's a privately held company run by these two, and they have no kids. A little bit of GIS history at UMass. UMass, has historically not been known as a GIS university per se. However, things have been going on behind the scenes for many years. And Julius Fabos in the Department of Planning and Landscape Architecture was actually one of the pioneers in the use of GIS for planning and landscape architecture. Maybe it wasn't GIS then, it was computer mapping. And so back in the 70s, he pioneered a lot of these techniques. And so just to talk about some of the connections, Marco Peño was one of his students there in planning. He was there at the same time I was at UMass. I was in geography, he was in planning. We never met, never crossed paths. In fact, when I was in geography, had no idea that planning was working with computer mapping. Well, Marco came back to his native Lisbon, Portugal, and created a wonderful GIS program, one of the most well-known programs in Europe. And now his university and my university in Spain have been collaborating for about 15 years now. We have a joint master's degree, we have a joint doctoral degree. I'm on the phone with Marco probably every week about one thing or another. And so it's funny how our paths have sort of crossed and then come together. On the right side here, we have Steve Maciek. Steve was teaching computer cartography, and he was running the Massachusetts Data Center in the 1980s. So he was on the UMass campus, and this is a picture that I stole from the internet from 1988. So this is how I remember Steve, because when I took computer cartography from Steve Maciek, he looked about like this. This is probably in 1984. And I remember him as looking kind of like a Steve Jobs character with the same kind of spectacles and super smart guy. Curiously, the course that he taught and that I took was at Mount Holyoke College. So I'd hop on the bus and go to Mount Holyoke every, whatever it was, Tuesdays and Thursdays, and studied computer cartography with Steve. And then the next semester, I became his sort of laboratory assistant, and I was kind of co-teaching that course with him. A decade before I was at UMass, Nick Chrisman was there at UMass, studied geography, was hacking around, and then left and moved to the Harvard Lab for Computer Graphics and Spatial Analysis. Became one of the renowned names there at the Harvard Lab. And he's written several historical books, including this one here, Charting the Unknown, How Computer Mapping at Harvard Became GIS. And so he became intimately familiar with the inner workings of the Odyssey GIS system, which was created by this guy here in the picture on the bottom in the middle with the ZZ Top beard, Scott Morehouse. So Scott Morehouse met Nick Chrisman and they worked together at the Harvard Lab. More connections. Scott Morehouse studied geography and computer science at Hampshire College way back when. And then, of course, Scott Morehouse moved to Esri and created ArcInfo. And, so everything is kind of connected there. Down at the bottom, I've added a more recent sort of historical artifact, which is the fact that the UMass planning department is actually quite well known for the use and the application of GIS around the world. So they're planners and they're technologists, people like Niels and Sasha, who I think some of you probably know. They're very well known for creating the UMass master plan, which is online and which is all sort of automated. Utilizing ArcGIS. They do a lot of their facilities management work, and it's connected to other systems. So they've actually been doing quite a bit of work on the facility side, which is also kind of nice. So I would kind of modestly stick myself here in the middle just to sort of illustrate the fact that our paths cross and everyone's pretty tightly connected, not just in the UMass world, but in general. This is the first of several of the points I'll make, that the GIS world is actually quite a small world. If you think the world itself is small and you happen to meet people around the world, well, in the GIS world, everyone's connected to everyone else. So I certainly know the people that Saida studied with at Santa Barbara. I know the people that Forrest studied with at Texas A&M, and the people that his people studied with at USC, and we're all connected intimately, right? Over here on the right, I've got this, you've probably heard of the Kevin Bacon number. Actors in Hollywood have this sort of, this funny Kevin Bacon number. So you calculate how many links or how many, how many connections are you away from Kevin Bacon. If you start in a movie with Kevin Bacon, then your Bacon number is 1, right? If you know someone who starred with Kevin Bacon, then your Bacon number is 2. So I just took a quick look and to see, what could I maybe have to do with Kevin Bacon. So it turns out that he and his wife did a cameo in a Will.i.am video way back when. And Will.i.am is buddies with my boss, Jack Dangerman. And so my Kevin Bacon number is 2. Well, if we were to apply this sort of kind of humorous linkage analysis to GIS, everyone would be a 1 or a 2. We're all very intimately connected. And I think that's a good thing. It's a very friendly community, very helpful community. Not a lot of sharks out there to make a fortune. If we want to make a fortune, we'd be somewhere else probably. Second point in my sort of tour of the state of the art or the status of GIS is what I'll call the name game. And so of course, GIS as a name has been around since the 60s. Some might argue that it should have been called the spatial information system because in fact, people are using the same techniques and the same software to study spatial phenomena at all different spatial scales and ranges. So we've got astronomers using our software and we've got microbiologists using our software to study relations between cells, or they're cutting open bones and doing cross-section analysis in anthropology and that sort of thing. So we might say that it should have been called the spatial information system, but anyway, it's called the GIS. And most of us recognize that that's kind of the umbrella term, and that's sort of good enough to talk about what most of us are doing. But of course, there will be contentions and there'll be arguments on social media and other places about the fact that no, it should be called spatial technology, geospatial technologies, which is actually the name of our master's degree in Spain and in Portugal. We decided not to focus on GIS. We decided to focus on the technologies surrounding GIS. So that's one way to look at it. When I was at Buffalo, I studied GIS science, another way of looking at things. So we studied the theory and the sort of the methodologies and the concepts behind the scenes of the GIS software. Other people focus on GeoWeb and neurogeography regarding sort of the new sort of modern web mapping techniques. So lots of different possible names. And of course, people are still getting into arguments all the time about what GIS is and whether it's GIS, but in general, we encourage people not to worry too much about it, but there will be some distinctions for good reasons. Along that line, when I moved to Spain and joined my current university, I moved to an information systems department. So I'm now the geo guy in an information systems department, whereas people like Dan Goldberg at Texas A&M are the other way around. They're the informatics person coming into a geo department. It's nice to mix, of course. It's nice to have different perspectives. Well, one of the things I learned, very clearly in that department is that, a GIS is also an IS. As a geographer, I talk a lot about the GI. Well, the information systems people talk about the fact that, well, a GIS is like a hospital information system or lots of other information systems, like a biological information system, like an information system managing a city or, managing traffic, for example. And so we need to keep in mind the fact that GIS is an information system. These days, that means it's multi-user and distributed. It means it's not just sitting on your desk. It means it's connected with other people, with your colleagues, or with the rest of the world. And increasingly, an information system is not just sort of sitting on its own. Increasingly, our software in Esri is connected and integrated with other software systems, and I'll show some examples. So just something for us to keep in mind, sort of the modern view of GIS as an information system. So over here on the right, I'll see comments, or I'll see people talking about the fact that they're going to teach or introduce GIS with R, for example. And I think, is that really GIS? I don't know. It's spatial analysis for sure. It's interesting. It's useful. But do we want to call that GIS? Again, we get back to the name game. Third point here, I think it's useful to consider GIS as a project. And I learned this from Roger Tomlinson, right? So, going back to the father of GIS, he did a lot of consulting with Esri and with lots of other organizations. He lived as a consultant and did very well as a consultant. And this is his recent book. He died, of course, in 2014, but he was very, very productive. And one of the things he taught us is that GIS is a large project that is designed to solve problems as a team. It's not designed to make maps. It's not designed to do things just because, we think they're interesting. So he would take an organization through a serious needs assessment, and they would generate a huge list, sometimes up to 100, of concrete information products that needed to be generated by this system. How often do you need to ask the system or query the system about traffic in your city, or about the status of your construction on campus? And so, how often and what kinds of queries do you need to throw at this information system? And then that tells you what kind of an information system you need to build. That tells you what kind of a database you need to build. And so that kind of thinking, I think, is very important for us to keep in mind. And so from an Esri perspective, this is what we think of when we think of GIS. We don't think of a person sitting at a desk drilling down and doing some very detailed spatial analysis on one particular place. We think of an organization like the Panama Canal Authority. They've got this really interesting linear world, and they've got ships passing back and forth, and they've got traffic patterns, and there's all kinds of employees on the sidelines, let's say, helping the ships to move through the canal. And I took this picture here on the upper right. One of my favorite places on earth. I could sit there this is at the Miraflores locks at what's called the City of Knowledge in Panama. And it just happens that our Esri office in Panama is there right across the street. So I go and visit them whenever possible so I can visit the canal. And I'll sit there and drink a coffee all morning long, watching the ships come through. And it's really interesting. When we visited the control room, these people have, some serious problems and some serious circumstances to monitor 24/7 around the clock. And so they've got their dashboards and they've got their control panels, and everything is integrated with GIS. So that's what we think of in Esri when we think of a GIS application. Related to that are the typical logistics companies. This is another what we would consider to be a sort of a typical or prototypical application of a large scale enterprise GIS. So we work with FedEx, we work with UPS, and both of them have created a series of applications to help them to become more efficient. Obviously, they're going to spend a lot of money on a pretty sophisticated system, but then they're going to recuperate that in fewer miles traveled and that sort of thing. And as you can see in the UPS numbers here at the bottom right, they stood up on stage at our user conference and they said, we're saving, 10 million gallons of fuel every year. And, we're saving, we're driving 100 million miles, fewer miles per year, and we're saving a ton of money, not only using GIS, but by integrating GIS into their Orion system, which optimizes the routes and tries to minimize, amongst other things, the left turns that they need to take across traffic. Every left turn across traffic that they can saves them a minute here and a minute and a minute, and these minutes add up to a lot of money at the end of the year. So that's the kind of the vision that we have of GIS from the corporate world. As far as GIS users are concerned, as I mentioned, no longer is a GIS user, as we can see on the left here, and this is an advertisement from ARC Info from the 1980s, no longer is a GIS user sitting there at a lonely desktop sort of digitizing points and polygons. These days, a GIS user has multiple roles or multiple possible roles within a large organization. And this is just one particular organization I grabbed randomly off of the web. This happens to be the Wyoming Geographic Information Center. And you can see here that there's a kind of a central coordination organization that determines who gets access to what information. And you can see in the sort of the bottom corner of that graphic, you've got users of different types or different profiles, people who can edit information, who can view information, who can update information, and other people who can do, more or less. And so, there's a lot of people collaborating and sharing information. That to us is the sort of the modern way of looking at GIS. And the Esri ArcGIS software now is sold to these organizations utilizing that kind of a series of profiles. So these days, a large organization doesn't phone us up, doesn't phone up Esri and say, send me 27 ArcGISs. They say, okay, our organization, according to our user needs study, tells us that we need 45 viewers and 6 editors and 96 field workers. And these are profiles or packages of the software. So a field worker gets the right package of software to facilitate his or her field work. And a GIS professional gets, let's say, full access. This is the person who's going to be creating, publishing, managing, providing access to other people. And so this is the way that the users are working these days. They've got their profiles and they have their particular types of access. Fifth point here, along the same lines, GIS is, it's transforming pretty radically. It's growing. It's growing from some of our perspectives, sort of out of our own control. I can't say that I'm an expert on all of the ArcGIS platform these days because it's growing in every possible direction. So it's not only up in the top right here, it's not only what we call a system of record, which is the traditional system which kind of archives and retrieves geographic information. But now increasingly it's connected to real-time tracking of vehicles, of customers, of elephants or whatever. It's connected to advanced spatial analytics and people who are doing data science. It's connected to the world of geo AI and machine learning. Down in the bottom, in the middle, applications of all types. I mean, there are some users who don't want the full GIS. They want a particular application to collect data, or they want to be able to tell their story as a researcher using story maps. And so increasingly now, this sort of constellation of products and of types of use of GIS is becoming at the same time interesting and also challenging for us to try to keep up with. And this is kind of a similar view, but if we start here at the desktop, this notion of a connected desktop is very important to us because, as I've said now a couple of times, people aren't sitting at their desktop saying, here's my data on my machine stored on my disk. Now we're essentially visualizing information which happens to reside on the cloud, and we're processing that data maybe on some other cloud. And we're then providing that information to a user who might be somewhere else. So we've got several different locations where the user is, where the location of study is, where the data happen to sit, where the processing happens to sit, and where the receiving sort of customer happens to sit. So there are these 5 sort of interesting different locations for us to consider. I mentioned geo AI, so this is big. There's a lot of demand for this. A lot of customers are asking Esri about this, and a lot of academics are getting involved now in machine learning and deep learning. And in many cases, they are applying very well-known deep learning, machine learning frameworks, or utilizing these frameworks available in open source and provided by the Microsofts and the Googles and lots of other big companies and big organizations out there. And they're integrating it in with their ArcGIS. And so they're sort of doing the best of both worlds. You use the machine learning platform to do what it's best at, and then you bring the result back into ArcGIS to do some of the geoprocessing, or vice versa. You prepare the geospatial data within ArcGIS and you send it out to do the machine learning, and then it comes back to you. So at this link here, and I can share the PowerPoint with you so you get access to the links later on. This link, you can get access to a typical sort of project. In this case, it's the Arizona DOT that would like to digitize all of its road signage and all of its road markers and its barriers and all the sort of furniture, let's say, along its highways. So they drive along with a car that's got all sorts of sensors and laser scanners and things on it, collecting all of this video, and then they submit the video into the machine learning process to extract, stop signs and, medians and, center lines and all the various objects that like they extract out of the video. And then, of course, because we're working in a GIS environment, we want to geo-reference all of these things. We want to know, not just that there's a bunch of stop signs out there, but where are they and when might they need to be maintained and that sort of thing. So this is a kind of a typical workflow where we're combining traditional GIS methodologies with newer methodologies coming out of the world of AI. Linked to that are things that I think are already happening in many places around UMass, which is people are starting to adopt Python notebooks as a way to access their data and access the GIS functionality as well. So the ArcGIS notebooks are specific versions of Jupyter notebooks that a lot of data science people know. And it's a way to sort of, let's say, hack in a little bit deeper to get access to the functionality of ArcGIS and to access their own data sources. And so there are a lot of data scientists who prefer to work this way, and so we're facilitating that. This is a large growth area for us, both for research and for teaching. I think the topic of equity in GIS is important, and this probably could have been higher up on our list. We don't want to leave this by any means for last. And I see on the Geosciences website, your own department website, you've got a diversity section on the website. I think it's important that we all do more along this line, not only to provide methodology so that people can utilize GIS to study inequalities and inequities and try to improve things in cities and in particular communities. But also we need to do more to encourage more diverse people to get into the GIS field. And I think that's the case for many technological fields. We all need to do more to have more diversity. We'd like to see a GIS community that reflects more so gender balance, but also racial equity and better represents our population. So we're doing what we can to move in that direction. We've got a team at Esri that's reminding us to be looking at things through a racial lens, amongst other ways of working. So I think that's important. We can all do more. Something which I think is very interesting, especially for, I think, young people or entrepreneurs, people who want to get started in this field, is that there's a sort of a new space race that's red hot now. Not only are space companies, private commercial space companies, acquiring others, and there's lots of mergers and acquisitions going on, and there's a lot of opportunity for employment at these organizations, but also countries around the world, including several across Africa, are launching satellites now. They have space programs. And so there's this deluge now of new Earth observation satellite imagery. And of course, Landsat 9 was just sent up about 3 months ago, and we're now getting access to that imagery. So there's this just deluge of new imagery available to us, and at all possible resolutions, and a lot of it freely accessible. So that's really important, I think, for a lot of our studies. Related to that is that all of this, huge quantity of information needs to be somewhere, it needs to be accessible. And increasingly, this is accessible on commercial platforms and also some non-commercial platforms. But these are the two big ones. Google provides access to its cloud for research purposes, and also the Microsoft Planetary Computer. And you might say they're kind of competing for researchers to jump on and utilize their cloud resources for compute and also for storage purposes. And so we work more closely with Microsoft, but of course, Google's doing fantastic work as well. There's a project called the Digital Earth Africa project, which is going on. It's being supported by a wide range of collaborators, including Esri, but it's being led actually by people from Geosciences Australia, and they're training a new team of Africans to take over the project, and it'll have its new headquarters in Cape Town coming up soon. This is a huge collection of imagery covering Africa in a so-called data cube, and a series of methodologies and learning materials, including Python notebooks designed to allow people to unlock this information. I should have said that a lot of this information, importantly, is what we call analysis-ready data. And so analysis-ready data is something that many of us didn't really have access to just a few years ago. Now the expectation of many scientists and many educators is that they're getting access to this, ARD, and they're able to just sort of move forward with their analysis. They don't have to spend a lot of time cleaning up and a lot of time correcting raw imagery, unless they really want to. Another portal or another platform is the Africa GeoPortal, which brings together data sources, learning materials. It's a community. And this is something which Esri actively supports with a bunch of other partners. And there's another one for the Caribbean, and we expect that other regions around the world, Middle East will probably have one, and Asia Pacific will have one. And these portals are nice kind of localized communities to bring people together for data sharing purposes. And so we certainly support all of those ideas. Behind the scenes of some of these platforms and some of these portals are Esri's data. And for many years, Esri claimed not to be a data company. We claimed, no, we're the software company. We're agnostic to the data. You bring your data and we'll provide you with the tools. Well, increasingly, we've been hiring people, we've been buying, we've been working, collaborating with organizations around the world to source the best available data in hundreds, literally hundreds of different data themes. So of course, not just, administrative boundaries, but all sorts of hydrological information and oceans information, bathymetry and demographics, and literally hundreds of different data layers that are now available freely. Most of it's freely available. There are some premium products that people would need to pay for, but most of it's freely available. And this has been a game changer for many researchers and many instructors, because they've got access to all this, huge repository of data to just start, basically, overlaying and working with. So if you're not familiar with the Living Atlas of the World, I would certainly encourage you to check that out. That's growing in leaps and bounds. I know that because every time I talk with this team, they're hiring more people. This is just one small example of the type of application that you would find in the Living Atlas of the World. This is the Sentinel Explorer, which allows you to dig into the latest Sentinel 2 and 3 satellite imagery collections. And this is an example of the way that people are accessing the imagery these days. They're not downloading, gigabytes of raw imagery and then messing around with it for weeks to have something which is analysis ready. They're hitting a service like this, which provides the analysis ready data for them. And here you've got the UMass campus. So in the middle there, you've got the campus pond, and then across the street, you've got Morrill and some other buildings that you're familiar with. And then I can go up here to the toolbar, and I can choose a rendering. So I can sort of classify on the fly this image. And I can say, I would like to look at a particular style of NDVI, or I'd like to look at, in this case, color infrared. And it does the classification on the fly. And if I move the image around to another part of the world, it does that classification on the fly as I'm moving around. So that's sort of the power of the cloud, and why we would like to, in many cases, keep the data on the cloud where they can be maintained and where they can be curated, rather than downloading it. And then, of course, what happens? As soon as you download the image, it's old, right? This is an image from October 29. Well, as soon as I download it, it's old, right? There'll be another image coming up in another week, and I'll want to get access to that as well. So that's the kind of analysis ready data that people are getting access to through the Living Atlas of the World. Next point in our tour around the sort of the state of the art is just a quick observation that I would make regarding the fact that I visited a lot of universities around the world. And if you're sitting at UMass or some other 5-college institution, you're accustomed to a certain level of infrastructure and everything works. And, of course, you're paying tuition and you're getting research money. So it should work, right? Well, it doesn't always work so well in many places around the world. So I can say that, number one, importantly, I would say probably every major university around the world is using some type of GIS, either for teaching or for research purposes. I haven't encountered one major university that's not. So there's always some little small group of GIS people somewhere. We would like to see that spread, and we would like to see people also digging a little bit deeper with GIS. I would say much of, and I'm not talking about North America, I'm talking about rest of world, much of what I see is that people are using GIS at a very basic level. So we're seeing lots of classifying images, we're seeing lots of sort of land use comparisons, year 1, year 2, really basic stuff, which is fine. So it means there are, theoretically millions of young people who are learning the basics of GIS. That's excellent. However, the excellence or the innovation, the people who are actually publishing the papers and coming up with new algorithms and demonstrating new ideas with GIS are actually quite clustered in not too many countries and not too many universities. So that we could do a better job at sort of, spreading out a little bit thinner around the world. Of course, it's not surprising that most of the GIS is being taught and being utilized in geography and in geomatics engineering departments. That's fine. But also we'd like to see more biologists experimenting with it. We'd like to see more health scientists. We'd like to see more people in business schools. And it's happening, but it's been a slow process. In general, what I see in places, and I've got a couple of examples here, Ho Chi Minh City down on the bottom and Kenya and Nairobi up on the top there. In general, there's a gross lack of data amongst the research community. Now that's either because they don't know how to find it, and although it seems obvious to us, so you just Google it, you find it, not everyone has good access to that infrastructure. And so unfortunately, infrastructure, both on the internet access side, but also on the hardware side, is still really lacking in many countries, and that's unfortunate. And so what happens is I'm seeing time and time again, another classification of a Landsat image, and time again, another analysis of some OpenStreetMap something, and we keep going back and going back and going back to those two fundamental data sets, which are fine, but they're probably not optimal for many things that we want to study. It's just that that's what's easiest for people to find, and that's their go-to data source. So we can do better there. I mentioned the infrastructure and hardware issues. So I guess the challenge or the opportunity is that we all, from the developed world, we can help. We can make visits, we can adopt departments and educators, we can help to teach, we can help on the research side. There's an awful lot of collaboration there that's possible. And we're doing our small part from Esri. We'd like to help people who would like to jump in and collaborate. So if you'd like to do that, please let me know. I think probably you're all familiar with story maps. Story maps is actually a big deal. Many of the story maps we see are kind of, fun, playful kinds of presentations. But surprising, or maybe not surprisingly, a lot of the, serious researchers, serious scientists at the NASA's, the NOAA's, et cetera, and I just, threw in a couple of other examples here. AAG is using it to talk about its membership drives and that sort of thing. The Cape Cod Commission is, presenting some really compelling stories regarding what needs to be protected and why, why they're protecting what they're protecting and that sort of thing. There's been a lot of attention being paid now to the use of story maps to tell the story that politicians need to hear, to tell the story that your dean needs to hear, your university president needs to hear, that important decision makers need to hear. And of course, we all know by now that you don't just throw statistics at people. You need to compel them. You need to convince them with stories. And so these story maps are actually becoming very, very useful, sort of after the fact. You've done the research, but now instead of just publishing it in a refereed journal, well, also turn it into a compelling story that the press will grab onto, that, the popular culture will grab onto. So this has become super important as sort of an add-on feature of GIS that, we didn't really expect, frankly, and it's been really impressive. Here's a story map, which is talking about the fact, this is just a reminder for me that, of course, as I said, we apply GIS at all different scales, including on other planets. So NASA JPL has been using ArcGIS for many years now to plan the landing sites for its rovers, amongst other things. And so, they want the rover to land in an interesting place where there are lots of interesting things to collect and to study, and they don't want to, land in the middle of some valley that they can't get out of, et cetera. So they study the planet pretty closely, and then they utilize GIS to determine this is the optimal location for landing the rovers, and so far so good. And this is a reminder to me as well that in the case of the ongoing volcanic activity on the island of La Palma, fairly near to where I live, on the Canary Islands, there's been a lot of work because the island itself is a very well technologically developed island. In fact, they've had this project called the Smart Island for many years now, utilizing ArcGIS. So when this all happened, we started getting, a huge collection of up-to-date geographic information from this Esri user there on the island, including some drone footage, which we took here and we overlaid the drone footage on top of three-dimensional model, et cetera, and we published it on social media somewhere. And some people from Nature contacted us and asked, "Hey, can we publish this in our journal? We would like to make this the image of the month for November." So they did. They published this as the image of the month. We were pretty happy about that. So this is, we got the credit here, Esri plus the Cabildo, which is the government of La Palma. And it's just a quick example of some of the compelling stories you can tell just with a single image. Number 13, GIS is going indoors. So of course, we normally study the outdoor world, but increasingly we're now studying our indoor world, where many of us spend 70, 80% of our time. And so there's a new product called ArcGIS Indoors, which we acquired from a company in Vienna, Austria. It was already a leader in indoor positioning and indoor navigation. And so this allows people to navigate within buildings, to build three-dimensional representations of their building, to manage space. This has, of course, been red hot now that companies are trying to figure out, or institutions are trying to figure out how to bring back employees post-COVID. How do we redesign the furniture? How do we decide how many people we can fit in each particular space? So there's a lot of that analysis going on, and that's connected to the world of BIM, or building information models. So this notion of GeoBIM is the melding, or sort of the combination of the GIS world with indoor GIS and the building information model world, which has been dominated by Autodesk and some of these other AEC companies. And so now we've got this interesting sort of interface between the two, and we're working together to create smart buildings, and you can do some pretty sophisticated analysis on interiors. Number 14, and I'm getting near the end here, we've been doing a pretty good job at integrating GIS technology with game engine technology. So game engine technology is, of course, the computer graphics technology that's utilized to produce fun and engaging video games. And people have always in the last 20 years or so, people have been kind of arguing, why doesn't GIS have the same awesome graphics capabilities that video games have? Well, now there's a possibility to mix these two worlds and to do a little bit better job at that. So our software integrates with the two most popular game engines, which are Unity and Unreal. And I can tell you, I've got students who love to do this. They love to build a model of their campus and then feed it into the game engines and add, interesting interactions. And, they've got, goblins and zombies and things around campus. And, they really love playing around with these two technologies. It's really, it's great for urban planning, for talking about new construction, and then, selling or convincing people that this or that other plan is the better way to go and that sort of thing. So there's some really interesting things happening there, combining game engines with GIS. Universities always like to talk about careers and about hiring. So I can say that this is a very good time as far as GIS careers are concerned in general. Specifically, this is the Esri website, but we're only one game in town. There are lots of our users, lots of other organizations that are hiring GIS experts. All one needs to do is to Google GIS plus careers, for example, and you'll find this career section here. This website, as of a couple of days ago when I put this together, it had 371 offerings within Esri. And of course, these are not all GIS experts. Some of them are marketing people or working in the warehouse or whatever, but most of them are working on GIS types of jobs. And one can search on job categories. It can also search on locations, because we've got more than 80 offices around the world. So it might be that someone wants to work on GIS, but would like to work in Dubai, would like to work in Singapore, would like to work in Miami. So we've got lots of offices doing lots of things. So as I mentioned, we're not the only game in town. There are many career websites, and I subscribe to some of them, and I get bombarded with offers all the time, not for me, but for my students. Of course, when people are searching, we're back to the name game. You can't always look for GIS. Many of these careers or many of these offers are called geospatial something, or they're called technology something. Sometimes the names are a little bit tricky, but if you play around with the keywords, you find lots of options. A huge growth area, which is not for everyone, but for people who are really interested in, getting a job and jumping into imagery, is the intelligence sector. So there's a huge intelligence sector, people who are analyzing satellite imagery, and I don't want to know what they're analyzing, but anyway, in places like St. Louis, Missouri, and Washington, D.C., huge market. So I mean, they can't possibly find enough people to jump in and help to work with imagery. So that's one possible way to go. Programming experience is always interesting, if not necessary. In the same way that if you're planning on selling cars, it's good to know a little bit about what's under the hood, a little bit about the mechanics. Having some program experience really makes it useful for working as a consultant or working in other facets of the GIS sector, and also applications experience. So we're always happy when applicants come to us and say, I know about GIS, but I also know about hydrology, or I also know about traffic, or I also study population growth or something. Some kind of substantive use of GIS is also really, really interesting for us. Wrapping up here, of course, climate action is top of mind for a lot of us. And so our team, our education team, but Esri in general has decided to sort of double down or even triple down on this topic. And if I had my preference, I'd like to see all GIS people around the world spending about half of their time on the climate crisis and the other half of their time on everything else that the world has to worry about. I think that would be very, very useful for us to do, at least for the time being. We need to focus more energy on this. And so these are just a few of the websites that Esri has been putting together, showing people that we've got lots of resources. We are paying attention to the climate crisis. We are helping people to find the right data, the right methodologies, the right storytelling methodologies, et cetera. And so we're certainly going to be moving in that direction. We'd be happy to collaborate with people in Massachusetts that would like to work in that same direction. So we'll be presenting some workshops on how to do this with Esri technology in the coming events. So maybe we'll see you at AAG in New York City, or maybe we'll see you at our education summit in San Diego. We'll certainly be pushing hard on this climate topic. By the way, I've been reading Catherine Hayhoe's book. I highly recommend it. Saving Us, a very, very good book about how to talk to people about the climate crisis and not get everyone offended and start getting into these black and white discussions. So summarizing, it's been a quick tour, but I hope you're convinced that GIS is still growing, very active. We're still hiring lots of people. It's becoming more integrated with other information systems. It's being more integrated into society. So it's touching the lives of more people. And we would really say, modestly speaking, that it's making the world tick. It's behind the scenes of lots of what keeps our world moving forward. We really love the community, a bunch of nice people, and I'm sure that you agree if you've been to GIS events. People who are collaborative, people who they want to help each other, they want to work on some of the world's important projects and problems. Lots of career opportunities, and again, lots of opportunities to take climate action with GIS, and we're happy to help out with that. And finally, we hope to see you at some future events, face to face, coming up soon. So with that, I will thank you for your attention, and happy to take questions because, of course, I left out things. I couldn't focus on everything. I talked about a few of the things that I see as I roam around the world and from the company perspective, but certainly I've left out things. So I'll be happy to take your questions or comments.
Well, thank you so much with this excellent summary of what has been done. And I'm mesmerized because there were really good points that I would like to see again and again, like the Charting the Unknown is my favorite book, and then how you started this story from there. And I'm sure people are eager to ask more questions. And you can type your chat, or you can just unmute yourself for your questions.
So you commented you're 6 steps from Kevin Bacon. I don't believe that. I bet you're closer.
Got to be closer.
I bet you're closer. Yeah, you need to meet Jack at some point. You need to come to a conference, and I will introduce you to Jack, and then you jump right up the ladder, right?
Perfect.
But certainly you're closer than 6. And like I said, in the GIS world, everybody knows everybody, and I know who Forrest studied with, and I know who they studied with. And the guy who taught the person who taught Forrest was in Montana and taught the guy who now is my boss at Esri. And I mean, it doesn't stop, right? Everything is just this tightly knit. I mean, the downside of that, of course, is that you need to behave yourself, because if you're in the GIS world and you do something wrong, everyone will know about it.
I was just having that talk with a student the other day about what kind of what kind of programs do this. Well, there's Illinois and Minnesota and all that kind of stuff. One of the questions I kind of had coming out of this mic, and for future viewers of this recording and whatnot, is I'm kind of curious, in your view, as you've seen all these jobs and all these changes in skill set. I love that you mentioned indoor GIS. That's my hot thing for the 2020s. But what are you seeing in terms of like job expectations or skill sets, knowledge, skills, and practices that are maybe missing from the many educational institutions that you visit and that you contact with? What do, in the higher ed space, what do we need to focus more on, do you think?
I think, of course, my vision is global. So I see a lot of universities that really need to get moving, and they need to, not just raise a level, they need to raise several levels regarding what they're teaching. I think what you're teaching at UMass is fine. I think it's great. I mean, I look at the curriculum, and we've talked, you're teaching, I think, what needs to be taught. At the undergraduate level, I don't think it's, I don't think it's a valid expectation for people to learn everything. You're not going to learn everything in 4 years. So, go get a good undergraduate education in something relevant. I mentioned, Steve Matchak, who taught me computer cartography. First degree in folklore, second degree in Welsh, in Wales. He went to Wales to learn Welsh. I don't know why. Third degree geography in North Carolina, and then he's teaching technology, right? So I mean, doesn't matter, So get a good undergraduate degree. If it can be something relevant like geography, all the better, of course. And then normally at the master's degrees, people start specializing and start getting a little bit more technical. And then now I'm going to become a programmer. I'm going to become an analyst. Or I'm going to become an imagery person. So I would say most of the North American universities are pretty much on track and, catching up with the trends and that sort of thing. Everyone's jumping into data science. Everyone's using notebooks. Everyone's programming in Python. So I think people are coming along quite well there. I think the main challenge is that, students, learners of all ages, they need to have as many hours as possible of practical experience. Now they can do that in class, but of course, it's not enough hours. So they can also do that outside of class. They can invent their own projects. They can do a GIS project for their club, their sports team, their hometown. So, the more hours you keep cranking away at this, the better. And that's why, actually, most of the North American universities are in good shape, because those universities have institutional licenses and they've got access to the software pretty much everywhere. So you go to the library and you find it, and you go to geography and you find it, you go to another department and you find it. That's not been the case in other universities around the world. It's still really kind of stovepiped in a few departments at many universities. And so a lot of people who could be using GIS never see it, never even hear about it, unless they studied with this one professor who's kind of hoarding the software. That happens around the world, and it's not doing anyone any good. But so the question is hours. How do you get more hours, right? When the software is now available on the web, on the cloud, awesome. So you learn something in a 1 hour class or a 1.5 hour class, but then you go away with your little team of 3 students and you keep cranking away at it all week long because you have access to it from Starbucks or from your dorm room or from anywhere. Right? I mean, that's been a game changer. So now we're seeing students coming to us with 1,000 hours of GIS experience instead of I did one project or here's my map, right? So that's been revolutionary. And so, anything we can do to provide students with the right tools to then be able to kind of do the rest themselves and put in the hours, I think we're in a good place. It used to be many years ago that people had basic GIS experience and we would hire anyone who could say GIS because we were so desperate. And then we would have to retrain them at the company, right? That's no longer the case. Right now, they're coming to us with, a lot of substantive experience because they can do a lot of it on their own once they're given some guidance and some fundamentals from the university system. So, I mean, another answer to your question is that we're still looking for sort of smart people who can figure things out. right? That's always been the case, right? We'd rather have a smart person who can figure things out and has never heard of ArcGIS than to someone who's like, oh, I think ArcGIS is awesome, but is going to be complaining all the time that no, something's broken, whatever. No, we're looking for problem solvers. We're looking for critical thinkers. You can tell in any one of your classes, right? You've got students who are like, yeah, this is awesome stuff, and you've got students who are like, no, my GS doesn't work. No, my GS doesn't work. Now what do I do? And it's like, we try to work at these two levels, but you might not want to hire that second person later on.
Yeah, and we're finding ways to build that kind of self-efficacy is something that's really challenging and really of interest to kind of turn develop that kind of critical thinking in people is I think GIS is a great way to do that, but it's certainly that difference in the way of thinking means a lot more if than knowing where the buttons are.
Mm-hmm, mm-hmm.
Oh, Calvin, you have a question?
Yeah, question. So if you ask Facebook what the future of the attention economy is, they'll say the metaverse. You ask Microsoft and Apple, they'll say augmented reality. How do those technologies play into GIS?
Well, it's interesting. I have a metaverse slide, which I decided to hide, thinking, I don't really need that. It's maybe just a buzzword. But why did I add it? Why is it there just in case? I think the metaverse is going to happen, right? And I mean, we don't know exactly what it's going to look like, and we don't know what companies or organizations are going to build it. But we're obviously moving in that direction. There'll be some kind of a fusion between the real and the whatever you want to call it, the artificial, and that's actually an interesting opportunity for spatially minded people, because this new world is going to have places. And it's going to have locations, and some of the locations are going to be real, and some of them are not going to be real. They're going to be generated, but we're still going to have these, spatial relationships and this connectivity. There's going to be a lot of work for people in computer graphics, a lot of work for people who are doing the gaming technology and all that sort of thing, to make things more realistic and more engaging and that sort of thing. So, from a careers perspective, I think it's going to be big for us. Whether it, turns society on its head and does crazy things that we didn't want, well, I don't know. I mean, of course, you can look at it both ways, right? We hope it's going to turn into something wonderful, but we see what social media is already doing to us, and it's hard to be optimistic, but we'll see. I'm not sure if that answers your question.
Thank you. Oh, yeah, it did. And then I was going to say
a question related to the clusters of research that you mentioned. That is like how the research is not uniform all over the world, but it's just in some regions it's done technically. And then when we think about these regions, it's basically like North America versus Europe. And and you also mentioned about how the naming, subtle like differences of European universities versus the United States, how the department names changes, and how even those names and the perspective behind those names are different too. So I'm also curious about your thoughts about this. Like, do you think this really affects the research direction that has been done in these clusters, or like these differences affect what has been done or what is going to be done in the future?
Yeah, I'm not sure that there's much of a connection between those two, but those are two good points. So what I meant by the research cluster, or by the cluster in innovation, is that, like I said, there are people who are teaching basic GIS around the world, and so if I just pick the sort of the random GIS graduate from anywhere around the world, I know that they can do basic this and basic that, and I have some basic expectations. But yet, their instructors are not publishing in the refereed journals. They're not really doing research. I feel for a lot of these people. They work in situations of a total lack of resources. They're badly paid. They're badly supported. They're being told to teach a zillion hours. How can we expect them to also be, awesome researchers? But but we would like them to participate in the research world, right? I mean, if we look through the research journals, they come from certain types of people in certain countries, and it's published in one language, right? So, we would like to have more people in more languages and more diversity participating. They all have great ideas. So if we sit around the table and have dinner with these people, they've got lots of great ideas, but they don't sort of structure them, or they haven't been taught, or they don't have time, or they don't have resources to structure them into article format and get them published. So it's not that people are not intelligent, it's that they haven't been trained in sort of the way that we at least expect, the research world to operate. So we could all do better to help, to make that, to change that a bit. Of course, it is changing a bit now. We've got lots of Chinese authorship in a lot of our refereed journals, right? The Chinese government obviously made a decision. They said, we're going to pay for translators, we're going to pay for whatever it takes, and we're going to give you quotas. You're going to start publishing like crazy in the refereed journals around the world. Well, surprise, surprise. Now some journals are inundated by Chinese authors. So we know it's possible, but it's not really happening in a uniform way around the world. So, we would like that to improve. To me, it's a little bit troubling that I see excellent instructors and professors in some of these countries who have left their country. They've gone to study in the UK or the US, whatever. They've done an awesome PhD. They were working with a group that's doing all this stuff. And then they return home, and then they're again trapped in their own bureaucracy, and the top professor doesn't allow the young professor to move forward, and they just get kind of stamped down, teach your class and shut up. So it's kind of difficult to see, but there's a lot of that going on. We'd like to see that change. Regarding the naming, you're right. It's a good observation. Not only do we have lots of names for GIS, we have lots of names for GIS departments and for faculties and that sort of thing. So there's been a lot of that going on over the years. Now we're geosciences. Now we're not geography and geology or whatever, right? I mean, these changes go on everywhere, right? And it's for marketing purposes, and it's going to attract more students, or it's what our field is moving towards. And so there's a lot of that, right? So we've got departments of geospatial, this, and lots of different variations. And I don't think that's a bad thing. I mean, it's a sort of, to me, that's sort of natural competition. And in some cases it's pure marketing. In other cases, it reflects the sort of the niche or the strength of a particular department or faculty, and that better represents what they do. So one of the things that I think is interesting, and I think it's not a bad thing, is that there are not too many GIS degrees out there, right? There are lots of master's degrees, which I think is appropriate. There are not many, hardly any undergraduate degrees in GIS, right? So, people I think are still recognizing that GIS is something you do within a substantive discipline. You don't only do GIS, right? So you're a geographer applying GIS, or you're a biologist applying GIS. And one of the ways that we apply it and become good at GIS is that we get a second degree, and then we drill into GIS. And that's when it's called, Master of Geospatial Technologies, or GIS, or whatever we want to call it. And that tends to be the add-on degree, which kind of specializes us. And I think that's appropriate. So I'm actually very happy that, we didn't see a proliferation of lots of undergrad degrees in GIS.
Any other questions?
I've got one quick question, kind of piggybacking off of Siddhar's last question.
Mm-hmm.
What do you see a possibility in the future of kind of shifting GIS into high schools, possibly senior year, development of AP tests, some sort of thing along that line? I've had thoughts about, I was a senior in high school, there was obviously no GIS courses available, and I think they're probably very limited, namely due to subscription issues in public schools. But I just wanted to get your thoughts on if you think that the community as a whole is heading in that direction to try to offer some sort of secondary element, and even possibly elementary education along GIS.
Well, the answer is that it definitely is happening. It's been happening for a while, and now it's actually it's speeding up. It's growing. we've had an education team in Esri since 1992, and they have been working with schools since 1992. But it's been a slow slog. It's been a slow process because, back in 1992, our system was this big unwieldy thing that if I were a teacher in high school, I wouldn't want to mess with, right? Well, now it's online, and now you don't have to install anything, and now it runs on a Macintosh. And now there are 100 reasons why a high school can do it now much more easily. I don't see it becoming an AP test. I don't think it's going to become a subject in secondary school. I think it's going to be a vehicle with which to teach math or to teach social studies or to teach, environmental science. And we're seeing it happen, in lots of different schools. All it takes is a crazy teacher who wants to do it. And so, it's one or two people who just, yeah, I'm on it. I'm going to do it. And they spend, all their extra free time that they don't have creating curriculum materials and doing that sort of thing. And so we work with a lot of these crazy teachers and they're doing that. There's a program in Virginia, which has been working for several years now, where they're teaching utilizing GIS in high school. And then those credits convert over to, I think it's James Madison University. And so they have this articulation process where, basically the smart kids are doing GIS in high school and then they're getting direct credit for that when they move over to the university. So it could happen elsewhere. It could happen, and it is happening. We work with offices around the world, and especially in Europe. That kind of thing is happening in the Netherlands. It's happening a lot in the UK. It's happening in France. Certain countries, it's really moving forward. New Zealand, Canada. So yeah, I think you'll start seeing more of that.
Thank you. And thank you for the great talk. That was super interesting.
Okay.
Do you know whatever happened to the AP GIS? I remember a call for proposals on that ages ago. Did that just kind of fizzled out, didn't it?
I think so. Yeah. AAG was pushing that and some other organizations. Yeah, I don't know. I think it's maybe still too niche according to, a lot of people's perceptions. Again, I'm also not in favor of it being a course per se. I think that the modular approach seems to work best. So, there are little bits and pieces that we could present to educators of any level, could work for universities as well. I mean, in theory, I could see all geography courses having some component of GIS in them, in the same way that, in a lot of study programs, there's some computer component of what you're teaching, right? So even if you're teaching history, there's some kind of computer laboratory component where you're doing some sort of digital humanities, right? I can see that happening. I can see bits and pieces of GIS being sort of part of everything pretty much that you study in geography or environmental sciences or that type of study program. Of course, that could be self-serving for us to say that, right? I mean, of course, we're accused of being the drug pushers and, we just want to get all these kids hooked on GIS. Well, yeah, we sort of do. It's not like we're asking them for money. We want to have a spatially literate society that understands that, with a little bit of technology, you can go a long way to solving certain problems. And that, hopefully they become decision makers and problem solvers and critical thinkers and all that sort of thing. As far as I'm concerned, if they're going to do that with someone else's software, that's fine too. But, we want people to move in that direction. And then, at the end, we'll all benefit from some portion of that, smarter, more spatially aware community in the future.
With regard to education, you speak about the smarter, spatially aware community. What area of the world is doing the best in terms of the education? Is US ahead or Europe or China?
Well, there are a couple of facets to that. One is that some countries have geography mandated in their curriculum at the national level. The US doesn't. US has these funny 50 states that are doing 50 different things, right? In some countries like the UK, like Canada, like Japan, and some others, it's in the curriculum, and when you get to a particular part in geography class in 11th grade, your book's got GIS in it, and that's it. You will learn GIS because it's part of the national curriculum. So some countries are ahead in that sense. I think US is doing a good job and Canada is doing a good job in general because, we're technologically aware, and we've got, you know, nice laboratories available. So, I mean, it's easy for those who want to teach it to do so. In countries where they might want to do it, but don't have the facilities, well, you know, it's going to be a non-starter. So yeah, it's a bit of a mix. It's interesting that when we talk to decision makers around the world, no one is against this idea of a spatial literate society. And in fact, some governments, like in the UAE, they jump all over it and they claim, you know, we're going to have the most, you know, sophisticated, spatially aware, you know, population, or whatever. You know, they like to make these big claims, right? They have a lot of money, so they think they can just sort of buy excellence, right? And so decision makers and politicians, you know, they like that idea, but you know, do they then implement what's necessary to make it happen? Usually not. It's a little bit trickier to actually make it happen. But I think, you know, just the fact that, you know, Google Earth, Google Maps is around. I mean, people have access to the basic technology one way or the other. People are getting the idea, right, that, you know, maps are useful and studying things on the map is useful. And, you know, now navigation is easier and now finding a hotel is easier. And, you know, people are starting to get the idea. But I think what a lot of the people don't realize is that you can continue doing that as a professional. You know, that there's more you can do than just sort of putting the dots on the map and, you know, finding the hotel.
Thank you.
Okay. I did a presentation earlier this morning to a development bank in Africa, and I showed them these kinds of things, these possibilities, and they were, you know, they were thrilled. You know, they were thinking, you know, we have an education division. We want our students to become 21st century, you know, learners. We want them to be decision makers. We want them to be programming. We want them to know about technology. And they said, you know, we never thought that, you know, one of the avenues might be through maps. And we said, you know, don't get too hung up on the maps. You know, the maps are nice, but, you know, we're making decisions. And it just happens that the data is being portrayed on a map. And, you know, and that gives us a particular pattern to help us to make these decisions. You know, behind the scenes, the students are learning all these technology skills and learning to work together and learning to, you know, analyze data and learning to, you know, these are some of the sort of the second order benefits that GIS offers. And, you know, these people were, you know, they were thrilled, like, wow, you know, how can we do more to, you know, integrate this into education? So we'll continue talking, but as I said, you know, actually putting it into place and getting teachers to teach it is a different story. It's tricky.
Any other questions or comments? Well, thank you so much for your time and this very interesting and
Okay, my pleasure.
Yeah,
my pleasure. And I hope other people can jump in and have a look at the recording later on. And
sure, yeah.
And,
We'll
you know,
upload this to the
everyone, please contact me if you'd like more information, or, you know, you've got some particular question. I'll be happy to be the conduit to find the right person to answer that.
We'll make sure this gets around. Thanks so much.
Thank you.
Okay,